Okay, so let's go to page 15, the bottom of page 15. We have the equations of circles. Equations of circles, so equations of circles. We have x minus h squared plus y minus k squared is equal to r squared. Okay, so this is the standard form of circle where the center is h and k, and the radius is r. Okay, so this is what the standard circle equation looks like. So let's find out, take a look at this, where this comes from. Okay, so let's start with the most basic of all basic circles. Okay, so let's say I have a circle with a radius of 1, where it's centered at the origin. Can anybody tell me what we call this circle? There's a special name for this circle. No takers? All right. This is called the unit circle. It's called the unit circle because the radius is 1 and it's the origin and it's centered at the origin. Okay, this is called the unit circle, and you will become very, very familiar with this in the second semester. Okay, when we start doing trigonometry. All right. Anyway, so this is a unit circle because it is centered at the center is at the origin and it has a radius of 1. Okay, let's say that I had this circle. Now I'm going to move or translate this circle to over here, from here to here, or this is going to be 3 and 2. But if it's since I moved it, since I just translated it, okay, the radius is still going to stay the same, right? The radius is still going to stay the same, right? So let's go back to this guy. If you look at this equation, what this says is that this is going to be x minus 0 squared plus y minus 0 squared, because it's at the origin. It's going to be equal to 1 squared. X squared plus y squared is going to be equal to 1. Okay, this is where we start with. And I'm going to go ahead and translate this over. So I'm going to move this in the x direction 3 to the right. Okay, if you remember in Algebra 2, Algebra 1, we talked about moving it to the right and to the left. So when we move to the right, we instead of x, if we're going to move it to the right 3, we put x minus 3 where x is. So it becomes x, where x is, I'm going to put x minus 3 squared, okay? And then y, I went up to, right? I went up to, when I go up to where y is, I'm going to put y minus 2 squared, and that's going to have the same radius. So it's going to look like this. Can you see where this actually comes from? So this is kind of like starting with x squared plus y squared is equal to r squared, and you're moving, translating that circle around to where the center is now h and k, x minus h squared, y minus k squared. Okay, all right? So that's where this equation comes from. Are there any questions on that? Okay, that's on the bottom of page 15. Let's flip the page. Let's do example number 6. So we can do example number 6. Example number 6. A, write the standard form of the equation where the center is -4, 1 with a radius of 8. With a radius of 8, so we just plug and chug in here. I get x minus h minus minus 4 is going to be plus 4 squared plus y minus 1 squared is going to be equal to 8 squared. Okay, so that's A. And then B, our center is what? 0, 0. And radius of 5, so it's going to be x minus 0 squared plus y minus 0 squared is 5 squared. All right? Yeah, that's easy enough. All right, let's continue on with example number 7. Example number 7. We can state that the distance between x and minus 3 is less than 9. So distance between x, so this is on a number line, again, number line, right? So distance between x and negative 3, right? And is it n? Is it n negative 3? Okay. The distance between x and negative 3 is less than 9. So you're going to end up with something that looks like this. Okay. So can anybody tell me how to solve this? How you would actually solve this? Does anybody have any idea how you would solve this? X plus 3 is less than 9, which means that x plus 3 is going to have to be between 9 and negative 9, correct? For the absolute value of this to be smaller than 9, it has to be in between here. If I subtract 3 on both sides, so that would be your answer, right? Not that we're solving for it, all we're doing is expressing the distance, okay? All right. Example number 8. Verifying the right triangles. We have 3 points. Use the converse of the and the distance formula to prove that the points determine a right triangle. So they're telling you that it does form a right triangle. You just need to prove it. Okay? So I have negative 3 and 4, 1 and 0. So here's 1 and 0. Negative 3 and 4. And then I have, what's the third point? 5 and 4. Five and 4. So we'll call this point A, B, and we'll call this point C. So let's find the distance AC. AC is going to be the square root of A to C, right? Actually, there's no square root, right? Because actually the Y is going to be 4 and 4. They're on the same height. So it's basically 5 minus minus 3, correct? So what is that? There really isn't anything to do calculation-wise here. It's going to be 5 minus from here to here, so that's going to be 8. All right, that was AC. That was quick. So let's see if we can find AB. AB is equal to from here to here. So I'm going to go 1 minus minus 3 squared plus 0 minus 4 squared, which is going to be the square root of, this is 4, 16, plus 4, 16, square root of 32. Okay. BC is from here to here, so I'm going to go square root of 5 minus 1. Squared, 4 minus 0, squared. So this is going to be equal to square root of, again, 16 plus 16 here, square root of 32. So yes, indeed, it looks like the square, if I square this and I square this, I'm going to get 32 plus 32, which is the square root of this, right? If I square this, it's 64, right? So in other words, AC squared is equal to BC squared plus AB squared. So yes, indeed, it is. The Pythagorean theorem works. So it is a right triangle. Not only is it a right triangle, what kind of right triangle is it? Anybody? Sam. Hello, Sam? Unmute yourself, Sam. What kind of right triangle is this? All right, Sam's having some technical difficulties here. Caden, what kind of right triangle is this?
I'm not sure. All right,
Anybody?
one.
45, 45, 90.
Who said that?
Brady.
Brady is correct. 45, 45, 90. Which is called it's an isosceles right triangle because this length and this length are the same. These two are the same, okay? Right? Quick reminder here. If I asked you on the test, what was the length of AB, okay, and you gave me this answer, you would not get full credit. Can anybody tell me why you would not get full credit? Why would I not get full credit for this?
You can simplify it.
Exactly. You can simplify this, correct? 2 times 16 is 32. 4 root 2, correct? So this would be the correct answer. All right? Okay, so that's example number 8. Let's go to example number 9. Example number 9, using the midpoint formula. It is a fact from geometry that the diagonals of a parallelogram bisect each other. Prove this with a midpoint formula. Okay, so 9, I believe. They're giving you this is A and AB. Okay, AB. And this point is C. C0. Obviously, this is the origin. Okay, so I went from here to here. This triangle and this triangle. So this triangle here and this triangle here are going to be congruent. They're the same triangle, right? So from here to here, this is C. And then from C, I'm adding A. So this guy, I'm adding A here to C. So this is going to be A plus C with the same height, Y direction, the same height of B, right? So everybody see where I get that A plus C from? That is the crux of this problem. If you understand that, you're good to go. So the midpoints here and here are going to bisect each other where this line and this line are the same. This distance and this distance are the same, okay? So using the midpoint formula, if you look at this guy, we'll call this the midpoint M. Using these 2 points, what do I get? M is going to be equal to this guy plus 0 divided by 2. And this guy plus 0 divided by 2. Right? If I look at this as the midpoint of these two, what do I get? I get A plus C divided by 2. I get 0 plus B divided by 2. Lo and behold, they are the same point. Okay, so that's our proof there. Okay. Any questions? Any questions on what we talked about today? Okay. So what do you need to come out learning today that you have learned today? You learned the Cartesian plane. We learned the 4 different quadrants. We learned the distance formula, the midpoint formula, and equations of circles. So that's what we really kind of touched on today, all right? No questions? All right, if there are no questions, go ahead and continue to work on your homework. Again, I will still be here for you, so if you have any questions, let me know.